Good evening, this is Peter Krischka. This is my discussion of AppArmor, HTTPS, and HTTP. Here are some acronyms that we're going to discuss in this course: Discretionary Access Control, Mandatory Access Control, Linux Security Module, and a few others. AppArmor. AppArmor, we have a Linux security module. And that implements, that's a kernel modification. It implements security policy. AppArmor profiles are loaded into the kernel, and there are two central modes, enforce and complain. This is a high-level overview of the security module. We've got a user space and a kernel space. So a user process makes a system call requesting kernel memory. So the inode is looked up, error checks, discretionary access control. And here's the important feature, LSM hooks. There are various hooks in this Linux security module. And the policy engine, that's where the AppArmor profiles are loaded. A little bit more detail about the LSM. The hooks are restrictive in nature. And then the policy engine arbitrates the permissions as so defined by the AppArmor profile. And I lifted this AppArmor profile. Here's an example of TCP dump lifted straight out of the training manual, or the manual for AppArmor. And then I further took a segment out of here, and this is capabilities. Now, this is within, if you reference back to the TCP dump, now capabilities are super user privileges that can be individually controlled. And for further discussion of this, you want to take a look at the Ubuntu man pages. And here's some more capabilities. Capability for sysmodule. Sysmodule provides the bin user TCP dump profile the ability to load and unload kernel modules. And this following statement is a variable and represents the location where the kernel virtual file system is mounted. And then here's an example of a conditional. So this one is going to deny audit capabilities for any file that's located under the bin directory. And that's an example of globbing. Now, globbing is this particular area bin, slash with asterisk, which means it'll match any file under root. And the MRWLK, that stands for, that refers to these abbreviations right here. And then again, this all came from, this is the link where you would find a very full discussion, very in-depth technical discussion of the AppArmor profile editing. These are some typical commands that we're going to use. This first one is the basic syntax of the AppArmor command. So it's sudo etc init.d AppArmor and then the command. And then down below you'll see I've got start, I've got status. The profiles, I said earlier, were located in the etc/apparmor.d directory, and that's where the profiles are located. But this particular command actually gets the profiles and installs them in your system. Here we go. This is the utility to start modifying those profiles. This starts the utility, and then we've got enforce mode and complain mode. Well, that's it for AppArmor. That's a brief overview discussion. Now we get into HTTP, which is Hypertext Transport Protocol. It's at layer 7 of the OSI model, and is designed to transmit raw data across the internet. And I'm being blunt here, but following discussions, I derived all of them from, or I distilled them down from the request for comment 2616. Now, parameters. The first one we talk about is protocol version numbers, which actually it may sound trivial, but it actually isn't. If a client is working with a older version number and it passes a request onto a server via gateway, it's important that the gateway and the server respond with the appropriate version number. Otherwise, the client is just not going to understand the response. And port 80 is the typical port that we work with, or the defined port, the typical. And timestamps are a universal time constant, or otherwise called Greenwich Mean Time, or Zulu if you've got a military mindset. The next aspect of HTTP is the message. And it's got 5 components. It's got request, response, header, body, and length. And there are very specific rules that identify the message length. And once again, you can refer to RFC 2616. Request. Request typically is initiated by a client and sent to a server. And the request begins with a method. And I'll discuss those methods shortly. But for example, get is a method. That's get, G-E-T. And the method will identify a resource identifier, which is URI, or what we commonly call today a URL. And then the client can pass the request modifier to the server in the header field. And once again, there are a lot of attributes that can exist up here. I've only listed 2. One is accept, and the other one is if match. But again, you can refer to 2616. Now here's the response. So the server can respond with a message, and there are various status codes, and there are 5 groups of status codes, which I'll discuss shortly. And the server can pass modifiers in the header field. An entity, I have to look this one up. An entity is the information transferred as the payload of a request or response. And you can see my reference at the end of this slide presentation. And the data type is determined by a header, but typically it's going to be something like text. Now, HTTP connections. Now, this is significant for us. Persistent is the word. A connection should be persistent. It should not just fail. And this, if you really get into networks, this to me is where the concept of sockets come in. But so you have a persistent TCP connection, and it's established to fetch the URL. And the concept behind a persistent connection is that it reduces network congestion. So the connection should remain open unless an explicit close is sent. And again, there are other conditions. Now, if a connection remains idle for too long time, there's a timestamp in there, and the connection will close. But both the client and the server monitor for errors and can retransmit. And if the server closes the connection, the client has an algorithm to continue. You may have seen this sometimes if you walk away from your browser and you time out and then you click again, the connection gets reestablished. I told you I'd get back to methods, and here they are. These are the 1, 2, 3, 4, 5, 6, 7, 8 methods that are defined in RFC 2616. The primary one is get, which retrieves information. A head would retrieve the meta information. No, it doesn't get the body. Post will request server information. Now, put, there's a difference between post and put. Put will actually store the entity that's supplied by the URI. Status codes, I mentioned those. There's 5 groups of status codes. 1 is informational, 2 is success, 3 is redirection, 4 is client error, and 5 is server error. Perhaps the most common one that you and I are familiar with is error code 404, which is the URL is not found. You typed in a bad address, or it's just that old that it doesn't exist anymore. HTTP also provides for access authentication. It provides for a challenge response authentication. I don't think this is the same thing as CHAPS, but that requires a little bit more in-depth. As Professor Green has said, research is never ending. Okay, the next one is content negotiation. Now, there are 2 primary, actually 3 here. There's the server-driven agent-driven and transparent, which is a combination of both. So both the client and the server can negotiate these communications. Caching. I have some experience with this, and I could tell you that I used to be an administrator on board a Navy logistics ship, and caching was really important to us. As archaic as this sounds, we had a satellite connection to the shore which was 64K. So imagine 120 people trying to do their banking on a 64K bandwidth, while you had a couple other yahoos trying to download videos, which I wouldn't allow because I blocked it at the firewall. But in caching, it improves performance in distributed systems. And what happens is, for example, in banking, we could download the primary web page of our bank site. And this way, when a user wanted to log in, they could just, the login page was cached, and then they could just send their credentials up to the banking site. Cache overrides are allowed, and the big thing over here is servers should provide an expiration time for how long that cache should survive. All right, and header fields. These are some attributes of the headers: accept character sets, encoding language ranges, age, allow authorization, cache control, whether it's public, private, or no cache. Excuse me. Now, security considerations. This is the heart of it, because we're talking about hardening concepts. Now, in HTTP, you get a lot of personal information or personal protective information, and that's really got to be secure, but that's going over the internet, and that has to be protected. And one thing to do is check server logs. Make sure that a malicious actor can't access server logs. And transfers, HTTP can't regulate that. It's just going to send raw data. So it's up to the application to control the transfer of data. Encoding can be enabled with the post and get methods. Now, privacy issues, applications should be programmed to warn the users that they're sending information over the internet. And to file and path attacks, recommendation is to use an absolute pathwise overlay directories. For example, if you say dot or dot dot would be an example of an overlay directory in a Ubuntu environment. And DNS spoofing, basically observe the time to live field with, typo, that should be DNS caching. And these are the references that I applied that from. We have, most of these are AppArmor and all the others, and the other one is the Hypertext Transfer Protocol. So that's my presentation. Thank you very much, and hope you enjoyed it. Bye-bye.